You can't use ASS. I know. I think it would be funny. I would play it up. You can't use ASS. And there's another one. What? AAA. You can't use AAA either. Okay, you cannot use that. So those are the two that you can't use. All of these you can. So let's take a look at some of these using ASA and AAS. So take a look at this one. It says, can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. So we're looking at this triangle right here and this triangle right here. So sometimes I just cover up one of the triangles if you have a hard time seeing it. And you say, oh look, I have angle, I have a side, and I have an angle that is congruent to the other one. So what would that one be? So I can say yes by ASA. ASA. Okay? Now, this one here, we're proving whether this triangle and this triangle, excuse me, proving whether this triangle and this triangle can be, so sometimes if you have a hard time seeing, just look at one of the triangles. So I know that I have a congruent angle, and a congruent what? Side. So AAS. See it? AAS. Yeah. Got it? Yeah. Okay. So we can say yes here by AAS.
Like, how do you know what order to go in? Yeah, that's
consecutive. Consecutive. They have to be next to each other, basically.
But why didn't you like side angle?
Why didn't? Okay, wait. Back up. Ask me one at a time, and I'll tell you.
Why can't you do SAA?
Isn't that the same thing?
Yeah.
That would be the same thing.
But it's
Doesn't matter. It's the same thing. You're still using two angles next to each other and a side that's not next to them.
So does that mean
Not in between them.
SSA also can be done because ASS can be done? Yeah.
No, ASS cannot be done. Ever. Or SSA. Same thing. Forward or backward, it doesn't make a difference. You're talking about the two angles here and a side that's not between them. Okay? Either way you say it, it still means a side and two angles. Does it make sense?
Yeah.
Okay. All right, how about this one here?
No.
You cover one up, yeah. We've got AAA, no, no, no. Okay, can't do it, so no. Cannot do AAA. Because remember, with the patty paper, when we had the same angle measures, we could spread it out so the sides got longer, but the angles didn't change. So AAA does not give you congruence. Cool? Oh, look at the back. It's just two proofs. Okay. So, first of all, let's look at what they gave us. Always, always mark up your picture. They told me that AB is perpendicular to BC. Okay, I've got that. AB perpendicular BC forms a what? A right angle. DE is perpendicular to EF. That also forms a right angle. That's cool. AC is congruent to DF. All right, I'm going to mark that right on my picture. And angle C is congruent to angle F, which they gave us already. So cool. Now I'm going to look and see, what do I have? Maybe I just look at one triangle, as I've marked all the congruent bits. So I know that I have an angle here, I have an angle here, and I have a what here? So if I go in order, I have AAS. Yes? Yeah. So that's what I'm going to make myself prove, AAS. So what I did was, I started by going to what they always start with, what they give you. If you can't think of how to start by writing the givens. Okay? Given that AB is perpendicular to BC and DE is perpendicular to EF. Given that those two are perpendicular, I can say that angle B and angle E are how many degrees? 90 degrees. By the definition, I'm abbreviating definition of perpendicular lines. The more you say, the better. You can't just jump in and say they're perpendicular, because you got to tell me that they're 90 degrees or that they're both right angles before you can say, and I'm sorry, you can't just jump in and say that they're congruent unless you say they're both right angles or they're both 90 degrees. You have to state that first. Then I can say, so, I'm going to put a comma there, angle B is congruent to angle E, because they're both 90 degrees. All right, so far I've proven one of my angles. So I'm going to put an A here. I've proven that one set of angles is congruent. So then now I'm going to go back to what was given to me, and I'm going to write, given, you can do your angle or you can do your side. I'll say, I'll do the angle. Given angle C is congruent to angle F, and segment AC is congruent to segment DF. Let's say, okay, so this is my other angle, isn't it? Yeah? And this is my side. Wait a minute, so I have everything I need, right? I proved that these angles are congruent. I was given that those angles are congruent, and I was given that that side was congruent. Now I can state my congruent statement. I can now say, we can say, triangle ABC is congruent to triangle DEF by AAS. So if you just kind of go back in and prove each, make sure you've proven each point, then you should be good. Questions on that? All right, let's do the next one because it's fun. All right, given that angle CBF is congruent to angle CDF, I'm going to mark that right now on my diagram. Angle CBF is congruent to angle CDF. And BF is congruent to FD. I need to prove that triangle ABF is congruent to triangle EDF. Well, sometimes I have a hard time seeing what I have to do here, so I did this, and you don't have to, but maybe it'll help you see which ones we're trying to prove. These two. We're trying to prove that those two are congruent. So take a second and kind of talk with your partner or somebody, or just on your own. Decide how you would go about doing this with that, and we'll talk about it. Ideas? Anybody? Yeah, Sabina. No? Okay, Alexa.
The inside angle like of B and D are congruent because of the like corresponding angle or linear pair.
That's right. That's right. I would say that. Yes, very good. You can say that these form a linear pair, correct? And these do too. And since both of these angles are a linear pair with congruent angles, therefore they have to be congruent. So that's perfect. Okay, what else can we talk about here? Yes, Nicole.
The two angles like right next to F are vertical angles.
They are vertical angles, aren't they? So let's mark that. I'm going to do 3. It's kind of messy. Oh, now I think if I just cover up the 1, I can see that I would have angle, angle, side, angle. And I can go with that. So I'm going to try and prove that. Okay? All right, so I'm going to start with what's given to me and work from there. I'm going to say, given that angle CBF is congruent to angle CDF. It's getting there, it's getting there. All right, we can say that angle ABF BF, so I'm talking about this angle right here. I'm going to prove this angle is congruent to that angle right now. Is congruent to angle EDF by definition of linear pairs. Okay, so that proves the angle part. That's one of my angles right there. So I'm going to put angle right here. That's an A.
Do we have to put?
No, this is just if it helps you. You can do it. All right. Now, we were given the sides were congruent, weren't we? So that's easy enough. Let's just write that. Given segment BF is congruent to segment FD. Just to kind of finish the sentence, I put gives us, you don't have to, but a congruent side. So there's my side, there's my S. The last thing I have to do is prove that these angles are congruent. I need to state that. So I could say, all right, angle DFE, that's this one right here, is congruent to angle BFA by definition of vertical angles. Okay, so that's my A. So I've got my ASA. Now I can make my congruence statement. Therefore, triangle ABF is congruent to triangle EDF by ASA. Beautiful, isn't it?
Yep. So beautiful.